How are you? So today we are going to discuss about behavioral design pattern, which is in series of design pattern. In previous video we have learned structural and creational both design pattern, and this one was left. So this time we will discuss about it. So let's begin. So first design pattern is chain of responsibility. Chain of responsibility means we are passing the request to the objects, chain of objects. So chain of objects can perform your request. Let's assume you are going to transfer money, or you are going to take the loan. It's a chain. So you will contact to the loan manager, and loan manager will take your document, and that document will be forward to the manager, and manager will once approve, then finally it will goes to clerk, and clerk will release the amount. So like this we are just passing the object from to the different objects, chain. So chain of responsibility. Let's take an example. You can see this thing in a exception also. In exception handling also, let's suppose we are getting error, number format exception, and divisible 0, and this finally each and every class is responsible for that, and they are passing this message from one class to another class. So that's why we call it as a chain of responsibility. So as I told you, so let's begin the chain of the responsibility. How to achieve that? In chain of responsibility, sender sends this request to the chain of objects, and the request can be handled by any object in the chain. A chain of responsibility pattern says that just avoid coupling the sender of request to its receiver by giving multiple objects a chance to handle the request. For example, you are going to ATM, and ATM is designed for chain of responsibility pattern in the money. In other words, you can say that normally either receive the content referred to other receiver, and if one object cannot handle the request, then it will passes to the next receiver, and so on. So let's begin that. So we have taken one example that we are going to check each and every first one. We created one class, console based logger, and this is a part of logger class. So logger is a what? We have created one logger abstract class. From the abstract class we have created some instance variable. Instance variable will take the place into the memory at the time of loading class into the JVM, and we have defined one method that is called display log information, and this method is abstract method, so we have to give an implementation in a child class, and finally we will log the message. So this is our logger class, and in logger class we have extended to this, and debug class. In debug based logger also we have extended with the logger, and debug based logger having one method that is display log information based on the message, whatever message you are passing. So a correct message will be passed here. And error based logger, and this is also same extended with the logger, and error based logger we are passing the message to the respective message. So now from one abstract class logger we are having three classes for different classes: console based logger, debug based logger, or error based. And if I pass the message, automatically the respective class will be handle the message. So let's see, I created one object that is a logger. A logger class is responsible for logging your output. Logger class output information, we are going to put that. Logger class, we are going to put error message, we are going to put the debug message. So, and finally it will return us a logger console. So it's a type of logger. And finally, if I want to get the message, what type of message is given there, so only just I have to pass the information, just I have to pass the value, what type of error message I needed. So here you can see output information and message is given here, and output information of error message, output message will appear here, and debug message will appear here. So this is just a chain of responsibility. We are passing the message to the different classes. So in other words, we can say the chain of responsibility pattern is used to achieve loose coupling. My mistake, I have written wrong spelling. Loose coupling in the software design, where a request from the client is passed to chain of object to process them. Then object in the chain will decide themselves who will be the processing the request and whether the request is required to be sent to the next object in the chain or not. We know that we can have multiple catch block, try catch block in the code. Here every catch block is kind of processor to process that particular exception. So when any exception occurs in the try block, it sent to the first catch block to process that. If catch block is not able to process that, it forward to the request to the next object or in the chain. For example, next chain block may be catch. If even the last catch block is not able to process it, then exception is thrown outside of the chain of the calling program. So this is what we were talking about, the chain of responsibility. So let's move to the another command design pattern, that is command. Command is what? Command is simple to note the commands whatever I have given to the system, and according to that it will perform the operation. Let's assume you are going in a restaurant. Waiter will come and ask for the order, and according to your requirement you will ask for request, and you will note down all the orders, and that order will be passed to the kitchen, and from the kitchen, once it is prepared, and it will be served to you. And whatever order you have prepared, that same order command will be sent it to the reception, and on the reception they will prepare the bill, and according to that you have to pay the bill. And finally that same command will go to the account department. In account department you have that amount will be added into the ledger accounts. So this is a chain for accounts. So this is a real life example, and let's come into the system. In system we have created one interface, that name is action listener command. In action listener command we are going to execute the action. What action? Maybe you want to open that application, you want to close the document, you want to save the document, or different type of operations. And all the operation will be handled by only one interface, that is action listener command. So let's see. So we have created one more class, that is action open, and that is implemented with the action listener command. And finally we are going to perform the operation on a document. So that is why document object is required, and we have to perform the operation on that. So action perform, and in the constructor we have passed the object of document, and finally we are executing open and save command. And this is the same, similar to the open, and we are doing the save object. And this is our document. In the document is simple class that is having two methods. One is open, one is save, and as per requirement the document will be saved or opened. And this is the main menu. If you click on the file menu, and then you will get the 2 or 3 options, open, save, new, or something like that. So I will not go into the detail that much, but I'll give you the example in design pattern how that thing works. So we need to have the object of action listener command, because the interface works as a remote control for the command. So we are having a getter setter, and we are passing into the system, and 2 methods we have defined, open and save. And as per requirement we can open the document, we can save the document. You can see here documents are object we have passed here. Document we are going to open, and menus options are available, and we are going to open. So you can see here output is here, document open, document saved. So once again in a short, so command pattern says that encapsulate the request under an object as a command, and it passes to the invoke object. Invoker object looks for the appropriate object which can handle its command, and passes to the command to the corresponding object, and that object execute the command. So command pattern is used to implement loose coupling, and in the request response model in command pattern the request is sent to the invoker, and invoker passes to the encapsulated command object. The command object passes to the request to the appropriate method of receiver to perform the specific action. Let's say we want to create a file system utility with a method to open, write, close a file. This is what example I have given to you, and it should support the multiple operating system like Windows or Linux or Mac or etc. To implement our file system utility, first we have to first of all we need to create the receiver class that will actually do all the work. And since we code in the terms of Java interfaces, we can have the file system receiver interface and its implementation classes or different operating system flavors such as Windows, Linux, and Solaris or Mac, etc. So now next design pattern is interpreter. So the interpreter is, what is interpreter? So line by line we are converting from one source code to another target code. So you can say the JVM also is another type of interpreter which converts the bytecode to the machine level language. So that is a real life example. And now let's see the example here. So we have created one interface, that is pattern. In pattern we have written one method, that is conversion, that will convert, that is responsible to convert the whatever string you are passing there. and its implementation class we have given here. So its implementation class, we are going to convert whatever string we have passed. So we have given the priority. If I want to change the priority 1 2 3 4 up to 10, we can set. This is just similar to the threading, multiple threading. In thread you can set the priority. So postfix and characters, all the characters we are going to split from there. If you have entered some plus, minus, multiply, division, modulus, or some this type of characters you have input there, and it will separate automatically. So these, on the basis of these special characters, your string will be split. So this is a small code. So let's see this how it's working. Yes, you can see here. So I have given the a plus b multiplies c. So it is, after fixing that, a b c is one side and all the symbol special characters are one side. So this is what our program is doing. This is the base. This is just some algorithm whatever we have written there. So again I am repeating, interpreter design pattern says that to define the representation of grammar of given language along with an interpreter that uses this representation to interpret sentence in the language. Basically the interpreter design pattern has a limited area where it can be applied. Programmers are rarely using this design pattern. So we can discuss the design pattern only in terms of formal grammar, but in the area there is better solution is that why it is not frequently used. So this pattern can be applied for parsing the expression defined in simple grammar and sometimes in a simple rule engines. And you can use to define grammatical representation of language and provides the interpreter to deal with this grammar. The best example of the design pattern is Java compiler. This is what we have discussed, that interprets the Java source code to the bytecode and understandable by JVM. And Google Translator is also the example of the interpreter design pattern, where the input can be in any language and we can get output interpreted in any other language. And now next design pattern is iterator. So iterator is a interface, is a part of collection framework in Java. So this real-time example you can see there. And another example, let's say you are having a remote control of TV and you are having 10 channels in your TV. So if you are pressing a next, so continuously 10 channels will come, and after that 10 it will not go to the 11, again it will come back to the 1. From 1 again it will start 1 2 3 4, again 10, again it's a 1. So like this. Or if you are going reverse back, 10 9 8 1 9 after it's again 10 9. So this is some specific design, specific manner. This way manner only we can get the data. So here elements can be accessed in aggregate object or sequentially without exposing its underlying implementation. So this is a good example as a collection. So this is one of the behavioral design pattern, and it is used to provide a standard way to traverse through a group of objects. Iteration is widely used in Java framework, where iteration interface provides a method to traversing through the collection. Iterator pattern is not only about the traversing through the collection. We can provide the different kind of iteration based on our requirement. Iterator pattern hides the actual implementation of traversal through the collection and client programs. Just use the iterator method. Check out iterator pattern post, for example, and implementation detail. So let's see. We have created one interface, that is iterator, and iterator have a one method that is has next, and next that will return a string, and we are having one more interface, that is container. From the container we can get all the iterator values. So this is the implementation class for the iteration. So we have created a class collection of names. Collection names is container. So these are all the names are given there, and we have to implement the container. So get container, all the collection name will come here, and has next one by one each and every object will come in front of us. Then excuse me, then next object will come, and once the things are done, and it will return a null. So we can find that we have reached on the last object. So let's see that. So you can see here I have printed all the name of my friends. Those are there. Those are we have listed in the array or iterator collection, and one by one all the names are printed. So iterator design pattern is one of the most important design pattern. It's widely used in collection. So you know very well, without iterator is nothing is there in a collection. So let's move to the another design pattern, that is mediator. Mediator means nothing. We are communicating to the centralized communication. We are making centralized communication. So if X want to talk to the Y, then XY they cannot talk each other. They need another person who is C. So A will talk to the B by through C. So this is what. Let's suppose we are having one user class, that is a general ordinary class, and we are having getter setter, and we are having a chat room. In chat room we can send a message on the basis of user who is going to send the message. So this is a mediator. Room is just a mediator, and through this room each and every user can talk each other, but mediator, this one chat room is required. Without this we cannot. So let's see its implementation. So Mr. Robert and John, so two candidates, those are going to discuss together, and they want to send the message to them. Let's run this program. So you can see here with the date and time they are passing the message each other with mediator class, that is chat room. So again, mediator is a design pattern which is used to provide centralized communication medium between different objects in the system. Mediator design pattern is very helpful in an enterprise application where multiple objects are interacting with each other. If the object interact with each other directly, the system components are tightly coupled with each other. That makes a maintainability cost higher and not flexible to extend easily. The mediator design pattern focus on provide a mediator between objects for communication and help in implementing loose coupling between the objects. Air traffic, let's take another example, traffic controller. Assume if all the flights are talking together, then in sky there are so many flights and there could be the communication gap as well. So they are having a one traffic controller department tower, and that tower is responsible to connect other flights, so pilots can talk each other, and air traffic controller will give the instruction to the respective flight so they can land or can take off. So this is a good example. So again I am repeating. So design pattern used to reduce the communication complexity between multiple objects or classes. This pattern provide a mediator class which normally handle all the communication between different classes and support easy maintenance of the code by loose coupling. Mediator pattern falls under the behavior design pattern category. So next let's move to the another design pattern, that is memento. This is a very good design pattern, memento. In any word processor, let's you start a WordPad or Microsoft Word or some other text editor, and you start typing. Let's say I'm going to start. I'm using Ubuntu, so gedit for me, or so this is what I'm going to type, and this is not yet saved at all. This is not saved yet here at all. So this is what I have typed. This is not saved at all. If I want to remove this, then I can press Ctrl Z, Ctrl Z, Ctrl Z. So one by one each is going in the back stage, and if I do Ctrl Y, it will repeat. Again I can repeat that one. So both options are available. So this type of design pattern is called memento. So without saving the object, we are changing the state of the object. We are changing the state of the object. So to provide, it is another way to centralization. So memento design pattern is used when we want to save the state of an object so that we can restore later on. Memento design pattern is used to implement this in such a way that the saved data state data of the object is not accessible outside of the object. This protects the integrity of saved state data. Memento design pattern is implemented with two objects, originator and caretaker. Originator is the object whose state need to be saved and restored, and it is uses an inner class to save the state of the object. The inner class is called memento, and it's a private, so that it cannot be accessed from outside of the object. So let's see how we can implement that. So this is the one caretaker class. In caretaker class, we have defined different memento, different objects, and we will say we will add the objects, we will add the memento, like gave you the example in gedit. I am typing, so it means I am adding the object in the system. I am adding the object in the system, and it is returning the object. And this is our memento. Memento is a normal class. Without memento we cannot set the object, so it's a ordinary getter setter class. This is our originator. Originator is responsible to set the status, whatever the status there, set state, get state. And memento we can set or get. Let's run this program. So as you can see here, now current state is 4 and first saved state is 2, and after that second state we have saved 3. On the same stage we are updating that sequence. So originator we have created one object, and caretaker we have created an object. In originator we are putting the stage 1, stage 2, stage 3 something, and in the stage we are putting a memento according to that. And once the memento is set, then we can retrieve that. So you can see here, that is why the state is being changed frequently. So memento is a design pattern which is used to restore the state of the object to the previous state, and memento design pattern falls under the behavioral design pattern category. So let's move to another design pattern, that is null object. So have you noticed that how system can recognize that particular object is null, and how it can send exception to you? Your object is null, so null pointer exception you generally got. So let's go in behind that what happens actually. Null pointer exception. So in null object pattern, a null object replace check of null object instance. Instead of putting if check for null value, null object reflects a do nothing relationship. Such null objects can also be used to provide the default behavior in case data is not available. In null object design pattern, we create an abstract class specifying various operations to be done, and concrete class extending this class, and null objects class providing a do nothing implementation to the class, and will be used seamlessly where we need to check null values. So this is our abstract class. So in abstract class we have defined all the steps, what steps we have to take in. So we have to check boolean is null or get the value. And this is our customer factory. In customer factory we are having all the names, all the strings. In all these strings, abstract customer factory, and we are retrieving all the names, and finally it will return us null customer. Null customer is a class, so this is our class. So null customer class is implementing the abstract customer class. In there we have defined two methods. First one, return the name string to check if data is not available, then it will return the message not available in customer database. And finally is null. If it is null, then it will return a true. And check real customer. Real customer is also extended with the abstract customer, real customer, and the same implementation we have to do. And finally let's run our program. So you can see here all the customers are listed, and once list is done, after that it is saying no available in database, particular database is not available. So we can check that particular one database, we can check particular value, we can get it like this. So this is null pointer exception related to the null object. How can we get the null object? This is observer. So now next design pattern is observer. Observer is nothing, is just to observe the state of the objects, just like in share market. Each and every second whatever the activity is going on, according to that graph is changing, so according to the state change. So let's move to our system. Now we are having one class that is binary observer. If I am putting the data binary, then this class will be handle binary data, and finally this will check the state of the data, and this is hexadecimal observer, and this is our abstract class that updates the status. This is for octal system. Octal we can check here, and this is our subject. So in subject class we can pass list of observer. There are so many observers may be available, so we will pass the message to all the observer and we will notify them if the certain changes is implemented. So let's run this program. So first state has changed 15, and after that F is octal is 17 and binary is 111, and state is changed 10, then it is automatically says A state is changed 12, and binary number is this one. So let's repeat it. Observer design pattern is useful when you are interested in the state of an object and want to get notified whenever there is any changes in the observer pattern. The object that watch the state of another object are called observer, and the object that is being watched is called subject. Java provides inbuilt platform for implementing observer design pattern through Java util.observer class and util.observer interface. Observer is a class and observer is an interface, and however it is not widely used because the implementation of is really simple, and most of the time we do not want to end up extending the class just for implementing the observer design pattern, as Java does not support the multiple inheritance in the classes. Java Message JMS, Java Message Service, uses the Java observer pattern along with the mediator pattern to allow the application to subscribe and publish the data to other application. Observer pattern is used when there is one-to-many relationship between the object, such as if one object is modified, its a dependent object are to be notified automatically. Observer design pattern falls under the behavior design pattern category. So let's move to another design pattern, that is state. State means we are saving the state. State means it is used when object is changes behavior based on its internal state. If we have changed the behavior of object based on its state, we can have a state variable in the object that use if and else condition block to perform different action based on this state. The state design pattern is used to provide the systematic and loose coupled way to achieve this through the context and state implementation. And This pattern is a class behavior change based on its state, and the type of design pattern comes under the behavior design pattern. We create the object and we represent our various objects in a context subject object whose behavior varies as its state object change. So we have created one state interface, and this is responsible for checking the state of the object, and this is implement, and this is our normal class that is going to save, and is a getter setter class for saving the state and getting the state, and this is a class for start state. So this class will do the action according to the context passed to the class and save the state and pass the system. And finally, if we want to stop the action and then implement the state and doing the execute, we are going to stop the state. So let's run the program. So you can see here player is in a start, and once it start a state now, and then we are going to stop the player. Another design pattern is strategy design pattern. Strategy design pattern says, let's suppose you want to go to airport. In airport there are so many ways. You can go use bike, you can use bicycle, you can use taxi, you can use metro train, or so many. So you have to decide which implementation you require. All the implementation are doing the same job, but you have to select the best one which is suit your requirement. So state design pattern. So this is strategy. Strategy design pattern is used when we have multiple algorithm for a specific task and client decide the actual implementation to be used at runtime. Strategy design pattern, also known as a policy pattern. We define the multiple algorithm and let's client application pass the algorithm to be used in parameters. One of the best example of the parameter pattern is collection sort method, and take the comparator parameter, and based on the different implementation, the comparator interface, the objects are getting sorted in this system. So let's see context. We have created one class context, and in context we are putting the strategy, and strategy, whatever strategy we want to choose, execute this strategy. And this is add operation to add the numbers. This is for division, to divide the numbers. This is for multiplication, to multiply the numbers, and this is for subtracting. So this depends on the user which strategy they want to implement, and all the implementation is going through this interface strategy. So if user want to add the number, user want to subtract the number, multiply the number, and division the number, so they can do according to the requirement. So you can see the result is here, and 10 plus 5 equals 15, 10 minus 5 equal to 5, 10 multiplied by 5 equals 50, 10 divided by 5 equals to 2. So strategy design pattern is a behavior, it's a algorithm can be changed at runtime, and this type of design pattern comes under the behavior design pattern. And we create the object which represents the various strategy and context object whose behavior varies as its a strategy object. The strategy object change the executing algorithm for the context object. So let's move to another design pattern, that is template design pattern. Template design pattern is used just like you want to take